Welcome to my session about the Open JDK and Eclipse Adoptium. I'm Hendrik. I live in Dortmund, and yeah, since several years I'm part of the Java community, and I do a lot of things within the Java community. So I worked on JSRs and JSR expert groups. For example, I was, for example, part of the Java Bean validation expert group. I did several sessions around Java around the world. I wrote a book based on this. I became a Java champion and Java 1 rockstar. And some years ago, I joined the Open Jdk team with the goal to provide rock solid, tested, and enterprise-ready Java binaries that are totally free and free to use. And out of this, as some of you might know, Eclipse Adoptium has involved, where I'm currently part of the technical steering committee and of the program management committee. And this will be why I'm talking mostly about OpenJDK, because today this is, at least some time of my daily work I spend in these topics. So what I will try to cover today is an introduction of the OpenJDK. What is the OpenJDK? What does it stand for? What contains the OpenJDK? Then we will have a look at the Java release model, how new Java versions are released and how this will happen in future. Hi. Next, since we now have with Java 17 a new Java long-term support release, we will have a look at some new features and how these features evolved within the different Java versions. Then we will have a look at different Java distributions, especially what we are doing at Eclipse Adoptium and how we provide OpenJDK-based binaries. And if we have some time at the end, we can have a look at some tips for migration and how to migrate to more free Java versions and even to newer versions of Java, like from Java 8 to Java 17, for example. Okay, so let's start with the first topic, the OpenJDK. As some of you might know, the OpenJDK is like the open source part of Java, how you can call it. So Java as a product has been open sourced in 2006. This happened by Sun because at that time Java still belongs to Sun. Sometime later, Oracle took over the maintenance of the OpenJDK, since they bought Sun and therefore are now the steward of Java and they own Java, like the trademark of Java and the trademark of the OpenJDK and so on. And therefore, Oracle is today the main driver behind the OpenJDK. And the OpenJDK is somehow the sources of Java, where Java is built out of. It's a little bit cryptic, and it's not much better when you go like to the OpenJDK web page, because that web page is quite old. It's quite hard to find information on that page. And if you just go to this page to understand what the OpenJDK really is, how all of the parts of the OpenJDK are connected, and how out of this different distributions like, I don't know, Amazon Corretto or Adopt OpenJDK or the Oracle JDK evolve, it's quite hard to understand. So based on this, I would try to give a short introduction. As I already mentioned, the OpenJDK is the base of all these different JDKs. So it's not that you have the Oracle JDK and the OpenJDK. This is something that I often get questions like, so what is the difference between the Oracle JDK and the OpenJDK? And to be fair, this is a not correct question, because like all the other JDKs, like Bellsoft Liberica, like Adopt OpenJDK, Amazon Corretto, the Red Hat upstream builds, Azure, they are all built based on the sources of the OpenJDK. So they are all OpenJDK releases. Even the Oracle JDK is an OpenJDK-based release because they all use the sources that are defined and stored in the repositories of the OpenJDK. Next to these sources, the OpenJDK contains some structures. So the OpenJDK is organized in so-called groups and projects. Groups are named based on the topics that the people in the groups are interested in working on. Like there's a 2D graphics group, there's a core library group, for example, and there's a hotspot group, just to show 3 examples. And people that contribute to the OpenJDK and work at the OpenJDK are part of these groups. And these groups then work on project. So we have, for example, the 2D graphics group. This is a group, for example, that works on the Swing part of Java, that works on JavaFX, but in addition work on the general JDK project too, because at least the Swing and HWT are part of the JDK. And next to this, we have 2 definitions of like milestones and epics in the OpenJDK, and these are JEPs and releases. The releases are the Java releases that we know, like Java 17, Java 11, Java 8, and so on. And JEPs are like epics. And as you can see here, they have like unique numbers. We will see some examples later. And all these JEPs contain an epic that will be implemented in a specific Java version. So where is it JEP stands for? It stands for JDK Enhancement Proposal. And in general, a JEP defines a new feature that will be part of the OpenJDK and therefore will be part of Java. All this is open in the OpenJDK. Here I have just 2 URLs in the bottom. So one as an example for a JEP, which is JEP 395, and one for a Java release, which is the Java release of Java 16. And when you, for example, click on the URL of the Java 16 release, you will end on a page like this. And this is the release page of, so this is not Java 16, this is Java 13 in the screenshot. But here you see 2 interesting sections, the section features and the section schedule. And the schedule section is defined by the release train of Java. So when the release will come out, when it will be available. And you can even see it in the, so you can even see it for previous releases. And we have the feature list that contains all the JEPs that are implemented in this Java release. So in Java 13, we have JEP 350, 351, 53, 54, and 55 that are all implemented in this release. When a new Java version comes out and you ask yourself, okay, I read a lot in blog posts about new features of this release at conferences, I see sessions where people already know how all this is working and already show examples for all these new features. And you ever ask yourself, how do they know all this stuff? In general, it's really based in the JEPs. And most of those people just read the JEPs because the JEPs are really a very good description of the features. It's really a technical description of the features that are part of a Java release. And it contains source code, it contains example, it contains the goals of the new feature of the epic, the non-goals, and so on. So with this information, you can really all the time see, so what happens in a specific Java version, what are the new features that are implemented in this new Java version, and you can even see what are the new features that will come in the next Java version. So this is part of the OpenJDK 2 next to the sources. And as we've seen, there are people that are working in groups and are contributing to some kind of projects. So since the OpenJDK is open source, in theory, everybody can contribute to the OpenJDK. And while it's mostly Oracle who did this, and did this in the past and still do it, there are a lot of other companies and individual people that contribute to the OpenJDK. This has become much better within the last years since the OpenJDK has been migrated to Git and to GitHub. So today, all the sources of the OpenJDK are hosted at GitHub. There was a JEP, like we've seen before, that defined this migration and defined how the repository should look like at GitHub and so on. And this JEP has been implemented with Java 16. So starting from Java 16, all the sources of the OpenJDK are finally at GitHub. And that makes it really much more easy to do contribution to the OpenJDK, because whenever you did some kind of contribution to an open source project at GitHub, created your pull request, in theory it's absolutely the same when doing something to the OpenJDK. Maybe the code is a little bit more complex, but I mean, even in the OpenJDK, there are low-hanging fruits where you can start with. And within the last month, there were several people that did the first contributions to the OpenJDK. This is just a screenshot from some people from the German Java community that I think that is half a year, or September 2021, who did their first contributions to the OpenJDK. So it's not only big companies who do it. Based on this migration to GitHub, even individuals can now do these contributions. When having a general overview about the contributions, you can see, so here we see all the companies that have contributed to Java 11, and you can see that, yeah, Oracle did most of the work for Java 11, but there are a lot of big companies like Red Hat, Google, Amazon, ARM, and so on, that contributed to Java 11. And this has become more within the time. So here you can see it for Java 17. So while the part that Oracle did is still quite huge, but it's not as big as it was for Java 11, for example. And between Java 11 and Java 17, about, I don't know, 25 maybe, 25 companies contributed to the OpenJDK. You might know several of these companies, Amazon, Microsoft, Google. There are some names that you maybe have not heard. And for some of these companies, it's quite clear why they contribute to the OpenJDK. So we have some companies here that provide hardware, like CPUs. So we have Intel, for example. We have ARM that want to get the Java virtual machine running on their hardware, on their infrastructure as fast as possible. Based on this, they contribute to the OpenJDK. We have companies like, for example, Amazon, that has their own OpenJDK build with Amazon Corretto that they use for their cloud infrastructure and for customers that want to run Java applications within their cloud. But we even have some companies like, for example, Twitter. So Twitter does not have any Java distribution. They do not have any hardware. They do not have any, I don't know, public cloud or something like this. But these companies really contribute to the OpenJDK because they heavily depend on it. So Twitter, for example, all the services within Twitter are running on the OpenJDK, are running on the JVM. And therefore, Twitter, some time ago, Twitter started to do contributions to the OpenJDK to get things where they are interested in just faster and better and so on. And next to this, Twitter is one of the companies, and there are only a few on this planet, that really build their own OpenJDK binaries. So Twitter does not use Amazon Corretto or the Oracle JDK to run the Twitter services on it. They build out of the OpenJDK their own binaries where the Twitter services, microservices, whatever, are running on. And yeah, next to this, which, yeah, excuse me, sure? So why they build, so the question is why Twitter build custom builds instead of using, for example, the one from Amazon. So Java and OpenJDK and the JVM is mission critical for Twitter because their whole business depends on that. And based on that, they could use, for example, adopt OpenJDK or Adoptium Tamarind and know that they will get open and free builds even in the future. But when they started to do it, both were not there. So Eclipse Adoptium was not there and Adopt OpenJDK was not big enough. So Twitter has a chance to depend on a company like Oracle or Azure or Red Hat for their Java binaries. And if there is a problem, buy support at that companies and hope that they help them to fix issues fast. And the people at Twitter had a problem with exactly this and therefore decided to invest in the OpenJDK and invest in creating their own builds. Yeah, and next to this, we have a lot of distributions, right? So the one in the bottom are, like, for example, the Twitter distributions that are not available on the market or only some small distributions, but there are quite some really big distributions today, like Amazon Corretto, Adopt OpenJDK, Bellsoft Liberica, Oracle JDK, Azure Zulu, and so on. And they are all, so some are bigger in kind of the usage and the download count, but I think these are the really huge ones that are used quite often. I can tell some numbers later if you want regarding Adoptium and Adopt OpenJDK because we have the download count online, so it's visible for everybody. But in general, those are all the distributions that are out there on the market. So this was just a short introduction about the OpenJDK. And let's talk about the Java roadmap and how out of these sources and of this structure, new Java binaries are created. In the past, especially with Java 6 and 7, there was no well-defined release train of Java. In general, it was defined like this, okay, in the next Java release, we want to have like this 10 features, and the next Java release comes out once all these features are implemented. This is how it was done with Java 6, with Java 7, with Java 8. And based on this, the gap until a new Java version comes out was quite high. So as you can see, like from Java 7 to Java 8, it's like 3 years or something like that. And from Java 6 to Java 7, because this was in the time when Oracle bought Sun, and yeah, I mean, one big company buys another big company, there was always trouble. So there it even took longer to provide a new Java release. And the good thing here was that the period in that two versions overlap was quite high. So from Java 6 to Java 7, there's a period of 2 years where you get, or where you have got 3 updates of Java 6 and Java 7. And this was a large period that people used to update their, or hopefully update their Java applications from 6 to 7. Between 7 and 8, it was not that long, but it was even longer. It was more than a year, where you were able to get free updates for both versions. If you bought, for example, commercial support at Oracle, the versions stayed for longer. I think for Java 7, maybe there's still a chance to get updated versions if you have commercial support at Oracle. And this is exactly what Twitter don't wanted, right? They wanted to do this on their own and not pay money to another company that then works in a private repository, because this is what Oracle, and not only Oracle, other companies too did in the past. So for this commercial support, they forked the OpenJDK and continued to work in a private repository. So if you today buy like a Java 7 version from Oracle and another company that still has commercial support, you won't get the same. Because both, at some point in 2015, forked the OpenJDK state of Java 7 and started to work in a private repository to do like the fixes they needed to do for customers. And with the release of Java 9, the roadmap of Java has changed. So it became more strict, and there was a better definition of the roadmap. Because the roadmap was defined like, okay, we will provide a release each 6 months. So 2 times a year, a new Java release comes out. And we do not define the features that a Java release will contain. If once a feature is done, it will be part of the next Java release. And we do not care if the feature that we are currently working on will be in Java 19 or 20 or 21. It will be in the version that comes out after we've finished the feature. And based on this, we can easily provide a new release all 6 months. Next to this, some of the versions are targeted as so-called LTS versions, long-term support versions. At the beginning, when this roadmap was initially released, it was Java 8 and Java 11. And one point that was quite critical in that moment is that how this LTS works was not well defined. So for example, when talking about Oracle, the LTS is not free. So for Oracle, when you wanted to use Java 8 after, what is it, update 219 or so, that was released at the beginning of 2019, you are not allowed to use it in production. You are only allowed to use it in production when you have a commercial contract with Oracle. Same for the LTS versions of Java 11. You can just not use them in production without having a contract with Oracle. But this is not how all the distributions and all the vendors do it. There are some other vendors that, for example, provide LTS support for these versions for free. Like, for example, Azure does it, Belsoft does it, and Eclipse Adoptium does it too, for example, just to name 3. And this happens because the LTS is still developed in the open source. So some companies here at the point where the LTS started tried to fork the OpenJDK and tried to provide commercial LTS functionality. But some other companies, and the biggest company that had an impact here was Red Hat, started to do all the security fixes directly in the OpenJDK, in the Java 8 and Java 11 upstreams. And based on this, everybody was able to build new versions out of Java 8 and Java 11 based on the OpenJDK sources and have all the security fixes in it. And at the end, this is what companies like Azure or Amazon or Eclipse Adoptium is doing. They work together on these LTS versions in the open and then create their own versions based on it. And Oracle had another idea, and this does not work that good for Oracle because a lot of companies, a lot of people switched away from the Oracle JDK based on this because there were quite good alternatives. I already mentioned a lot of them. And yeah, this just ended in some distributions that are, I assume, more often used than the Oracle JDK today. So let's go really to today and see how it looks today. So we have Java 17 out. That is, again, one of the Java versions that is preferred as LTS version. And this preferred for LTS version means that, in theory, I could create my company and provide LTS support for Java 19. I mean, I can do it in the Open JDK, or I can even fork it and do it on my own. These versions are the ones that are preferred to provide LTS versions to not have different LTS variants and versions in the community. And after the release of Java 17, that is not that far in the past, again, some things has changed. So earlier, the plan of the Open JDK was to provide a new LTS release all 3 years, as we can see, like from Java 11 to Java 17 to Java 23. But this has changed, and the next, I don't know why I cannot switch with the keyboard on the next slide. And the next Java release will be Java 21, because from today, we will have new LTS versions all 3 years, all 2 years, to even have a faster support and a faster integration of new features in LTS versions, and based on this, a faster integration and usage of these features within the industry. From my point of view, this is a big success, but the marketing and press work on this was not quite good, because this was announced by Oracle as a steward of the Open JDK with the release of Java 17, and some other people and companies that are working in the Open JDK with the Open JDK are not well prepared on it, and they started to discuss if this is good for everyone after they announced it. Next to this, as some of you might have seen, starting with Java 17, Oracle again changed their plans and licenses. So after their release of Java 11, where they changed their license to a license that does not allow you to use Java, the Oracle JDK, for free in production. With Java 17, again, they changed their license that allow the JDK 17 binaries of the Oracle JDK, again, to be used in production. Sadly, they already define that this will happen till September 2024, and at the moment, nobody knows what will happen after that date. So it's again limited, but it's a better community support from Oracle than it was with Java 11. Okay, let me get some water. If there are any questions from the remote people, I can see the chat, so you can just write in the chat if you have any questions. Okay, so based on this release train, as mentioned, one of the goals was to have a better development of features, a faster development of features in the Open JDK, and have these features be part of a Java version once the feature is done. And based on this, between Java 8 and 17, a lot of new features became part of the Open JDK and of Java. So we already talked about the JEPs, and now we will just have a look at the different Java versions and the JEPs that are part of it. Before we see that, there are some JEPs that are quite interesting because they are general JEPs and not targeted for one specific version. There's JEP 0, and this contains a list of all the JEPs. So this is like a list of all epics that are somehow in any of the Java versions or planned for any of the future versions. Then we have the JEP 1 and 2 that defines the general workflow of the JEP. JEP 3 that defines the release process of the JDK. Those are not that interesting, but the ones that are interesting, and they are quite new, are the JEP 11 and the JEP 12. Because with the new release model of Java and releases all the 6 months, one goal that the OpenJDK has is to provide features as fast as possible to the community and let the community play with these features to get feedback. And to do so, they provide 2 new types of features, and these are preview features and incubator features. And to do so, the OpenJDK now has an incubator mode and a preview mode. And the preview mode is to enable new functionalities of the Java language. For example, text blocks that has been added to Java some versions ago. So by adding this -- enable preview tag to the Java compiler or the Java command, you can enable previews that are already part of the JDK, but targeted to future versions. How you can see what kind of previews are part of a Java release, I will have a slide about that in a second. And regarding the JDKs, here we can see the count of, not JDKs, of JEPs or so-called epics that are part of the Java releases. So as you can see with Java 8 and Java 9, it looks like there are way more of JEPs that are targeted to this versions and that are part of these versions. But this is based on the release period of this Java versions, right? Because between Java 7 and 8, there were 3 years. Between 8 and 9, there were, I think, even more than 3 years. So based on this, they were able to introduce like 50 or more new features in such a Java version, starting with Java 11. After 6 months, we had a new release. But you can see that there are about, I don't know, maybe 10 to 14 new features in each of the Java versions. And these features are really totally different. So we have new language features, we have new APIs, and we have even new features that as a Java developer you normally won't see, like the migration to Git, or like supporting new architecture or operation systems. Let's have a look at some of them. I think it don't make sense to see the list of all the different features. But let's have a look at, for example, at Java 12, where we have with the Shenandoah garbage collection, a new garbage collection that has been introduced to Java, which is a quite nice garbage collection because you can use it to free memory. Some of you might know that with the parallel garbage collection, you can have the problem that if your application uses a lot of memory at one point, then the memory is blocked in the operation system, and even if the memory within the Java application goes down, the Java process never releases that memory. With the Shenandoah garbage collection, you can activate that. You can even define how often you will check to release new memory to the operation system. So this is one thing that is not really a new API or a new language feature, but this is really something that happens under the hood. In Java 13, we had some of the first preview features. For example, we had a preview feature for text blocks. So starting with Java 13, with this -- enable previews, you were already or was already able to use this new text block features within Java and maybe use it in unit tests or something like that. So when I talk about text blocks, I mean this one, right? So that you can write a Java string in multiple lines in your IDE and do not need to do a concatenation of several lines of strings. Java 14, here we had a lot of different new features. What we see here are things that are not defined as preview, but defined as incubator. And against of the preview features, where you need to add a command line flag to use them, the incubator features are in a specific incubator package, because things that are defined as incubator features are always new APIs that you can directly use and use in your code as new parts of the Java standard API package. So here we had, for example, the foreign memory access API that allows you to directly access that memory, which was an incubator feature. The best feature in Java 14 are definitely the better null pointer exceptions, where you now really can see what is null. Even if you have like a concatenation of A.B.C, you really can directly see what in an expression is null and do not need to use your debugger to find out such problems. As said, a lot of new features in different Java versions. In Java 17, several of the things that were in an incubator state previously has been released. And here we have two additional new interesting things. One is that we see things that are deprecated and things that are removed. For people that are still on Java 8, maybe they don't know it, but it can become a problem, because in the past you said, Java write once, run everywhere, things get deprecated but never removed and so on. And this is not true anymore. So there are things, APIs, even public APIs, in the Open JDK, so in Java, that have been removed after Java 8. And things that are deprecated to be removed in future. How you can check this and see if this affects you somehow, we will see when we talk about possible migrations. Again, in Java 17, we had some interesting things happening under the hood. First of all, for macOS, we have a new rendering pipeline. Until Java 17, for macOS, everything was rendered based on OpenGL. With Java 17, Java can directly work with the API of Apple Metal, which is, from my point of view, something like DirectX, but not from Windows, but from Apple. But I'm not I don't know, native graphics guy. But this really has a huge impact on UI renderings on macOS, and having Java-based UIs even in the future on macOS, because Apple will remove the OpenGL support in near future. The other one that has been added is the support of ARM-based processors, and there in the range from Java 8 to Java 17 for Linux, for Windows, and for macOS, it has been added for all the systems. Microsoft, for example, worked a lot on the ARM support, especially for Windows, but as far as I know, they even helped on the support, ARM support for Mac. Unbelievable, right? 10 years ago, somebody told me Microsoft is the company that helps in an open source project to get it running on Mac. But this is how Microsoft is working today. yeah, so these are great new features, and yeah, even with future versions, Java 18, Java 19, and so on, we have new functionalities like the simple web server that is part of Java 18, which in combination with JShell or JBang let you start a web server, a full-fledged web server with one command line call in your shell, and you have a web server running, which is quite nice. Oh yeah, and things that UTF-8 will be used as the default encoding in Java instead of using the one from the operation system. So these are all the things that happened in Java. There are even here on Jack several, I think, Falk Sibach, for example, has a talk about new Java features that are part of Java 16, 17, and so on. So if you are interested in that, there are talks at the JAX, especially about that features. I just wanted to give an overview. And as mentioned before, now would like to leave the Open JDK and talk a little bit about what is happening one layer above, which means like how to use the Open JDK and all the work that happens within the Open JDK to provide Java binaries that all of us can use to write Java code on the one hand and execute and run business application on the other hand. And here, yeah, some of you might know, my distribution of choose is yeah, to be fair, it's not Adoptium, because Adoptium is the vendor, it's Eclipse Tamarin, but I like to use the things that are happening at Adoptium. And Eclipse Adoptium, as some of you know, is the successor of OpenJDK, that was and still is one of the biggest Java vendors in the world. So who's using OpenJDK or has used it in the past? Way, that's great, perfect, thank you. So you are one of about 300 million people, because we, with OpenJDK, even with having Adoptium, OpenJDK is still downloaded a lot, and we have over 300 million downloads of OpenJDK binaries. And based on this huge count, 2 years ago, we decided that we need to create a foundation, be part of a foundation or something like this, because OpenJDK was an idea of some people. Then the first actions of the group happened in the London Java user group, and till the end, the London Java user group was like the organization behind OpenJDK, and all the machines that I used to build Java for different operation systems and architectures are all paid by a credit card from the London Java user group. And you know, based on this, we decided to join the Eclipse Foundation and become Eclipse Adoptium as a top-level project of the Eclipse Foundation. And like we had it with OpenJDK, our main goal is to provide a free and open OpenJDK-based Java distribution that all of us can use to provide solid enterprise applications. And this distribution is called Tamarin. It's this logo. So a lot of people asked me, so OpenJDK is such a cool name. Why don't you call it Eclipse OpenJDK? Why Eclipse Adoptium? So the answer is super simple, right? It's based on trademarks. So not only Java is trademarked by Oracle, even OpenJDK is trademarked by Oracle. And based on this, since the Eclipse Foundation trademarks all their projects, all their top-level projects, and so on, we are just not able to call it Eclipse Adopt OpenJDK. So it's really a trademark program. This explains it quite good. You see all the trademarks that are affected in it. And just a nice side story, do you know who owns the JavaScript trademark? Who knows who owns the JavaScript trademark? Nobody? Oracle owns the JavaScript trademark. Because of that, we do not have a JavaScript foundation, but we have a JS foundation. And now, what big company is not part of that foundation? Just a side story regarding names, trademarks, and so on. So this is why we needed a new name. And then the next question is, okay, now I understand why you call it Adoptium. Okay, it sounds a little bit like Adopt OpenJDK, sounds nice. But now you have this Tamarin distribution. Why don't you call your distribution Adoptium? To be fair, here we are just convenient, like others are doing it, right? So we have, for example, something is, now it's working. So we have, for example, Azul that provide Zulu, or Amazon that provide Corretto. So you always have a vendor and you always have a product. And if you create a new company around a product, and you talk with people who already did this, all of the people will tell you, never name your company like you name the product. Because maybe in 10 years, you don't think about that product anymore. You want to do something else, do something completely different. So do not name it after the product. And that's why we decided to call it Tamarin. And if using the name Tamarin is not the best name. So who likes the name Tamarin? Who thinks Tamarin is a great name for a Java runtime? Who thinks Tamarin is a stupid name for a Java runtime? Okay, so I will tell you why it's the best name. Okay? So first of all, okay, fair enough, right? But somebody already mentioned this. This is only half of the truth. Next to this, tamarin is the chemical, not element, I don't know, chemical thing that is the nearest one to caffeine that we have in our world. So tamarin is not only an anagram for runtime, but it's a chemical thing that is as near to caffeine as possible. So, is there any better name for a Java runtime? Yeah, sure. But once you know it, you understand it. Because Red Hat, yeah, that's a good question. Yeah. No, I don't know if this is trademarked, for example. So the Eclipse Foundation trademarks all their project names. That is, you cannot create a top-level project as the Eclipse Foundation that is not trademarked. And I assume that, and at Red Hat, is it really called Red Hat OpenJDK, or is it called Red Hat Upstream Build? Or OpenJDK Upstream Build? To be fair, I don't know. Yeah. Yeah, that's the point, right? So at Adopt OpenJDK, we provided the Red Hat build on our website too, and they were named as Red Hat OpenJDK Upstream builds. So the OpenJDK is somehow in this name, but it's something different than Adopt OpenJDK, right? Yeah, so this is why we have named the new distribution Tamarin. And since we are now at Eclipse with Adoptium as a top-level project, we are able to invest in additional things. So next to the Tamarin runtime, we are investing in additional projects. Currently, we have 3 projects under the Adoptium top-level project, and Tamarin is just one of it. The second one is Aquavit. Anybody already heard about Aquavit? Nobody. Cool. So Aquavit is a test suite for Java runtimes. As we've seen earlier today, there are now a lot of Java runtimes out on the market. And what Aquavit is, it provides a full suite with a lot of different tests that can be used to test a Java runtime and verify it that it's, yeah, just enterprise ready, working. And in the OpenJDK, and this is quite sad from my point of view, because the OpenJDK does not contain much unit tests. And in Aquavit, we now have a huge set of unit tests that can be used to test Java binaries. And Eclipse is not the only company that is using it. Azure already use it. Microsoft already use it. IBM already use it. Red Hat already use it. So a lot of companies that are using it. Yes, there's a question? That is a good question. Maybe this will happen in future. The problem is that Oracle has the TCK. So the TCK is the test compatibility kit that Oracle provides as a closed source product so that companies can run this, and if it success, call them their binaries Java binaries. Without running the TCK and without running it successfully, which is never checked by anybody because it's closed source, nobody can check it, so you just need to say, hey, it worked. Anyway, so by running these against your binaries, you are allowed by Oracle to use a Java trademark. Without using this, you are not allowed to use the Java trademark. And since it's closed source, you need to sign a contract with Oracle that you are allowed to run these tests against your binaries. So Oracle has a kind of business model to check if binaries are Java binaries, right? And based on this, Oracle is not that much interested in having something like this as part of the OpenJDK. This is one big benefit that we have with becoming part of the Eclipse Foundation, because with the Eclipse Foundation, we were able to talk with Oracle in a way that finally we are able to sign the OCTLA, which is the contract that you need to sign to use the TCK. And with the Tamarin builds, we now prove the TCK against them. So all Tamarin builds are TCK proofed next to this Aquavit proof. At Adopt OpenJDK, that was not the case. So at Adopt OpenJDK, Oracle does not allow us to run their TCK tests against our binaries. But anyway, so we have a lot of tests. So it's like 250,000 tests. And so you normally have different, so at the moment you have Java 8, Java 11, Java 17, Java 18, and so on. So I think that number is not perfectly correct anymore, but at Adopt OpenJDK, whenever we created a new Java binaries, we built them on 58 platforms. We had 6 different versions, and Aquavit contains 250,000 tests, which means that we executed 87 million tests for each release, so over all the platforms. It takes a few minutes, yes. So the tests are separated in 6 different groups, and the groups can be executed in parallel, so like for each binary. And as you can see, the first group is the group OpenJDK. This contains the tests that are part of the OpenJDK, and here you can see that it's not that much. We have some functional and system tests. Those are contributed by IBM. Then here we have the JCK, which is a Java TCK. So this is already part in Eclipse Adoptium. So this is an old slide. I need to change this. One nice thing is the performance group, where we have benchmarks. So we execute benchmarks to check that a new Java build, a new Java version, is not slower than a previous one. And we have this external group. And this is a quite nice trick, because this contains about, it's even more now, maybe 150,000 tests or something like that. And here, so whoever written 125,000 unit tests? Right. So we neither. And what we are doing here is we use the unit tests of other programs, applications, and tools. For example, we use the TCKs, so the tests from Eclipse MicroProfile. We use all unit tests and integration tests from Tomcat, or for example for DerbyDB, which is a in Java written database. And we do it like this. So now for this, especially for this external group, right? So this is done like this. So we have our Aquavit test, and to run a test, we create somehow a container or isolated infrastructure. So we cannot do everything in containers, depends on the operation system, but for some we can create, for example, a Docker container, copy the JDK that we want to test into the Docker container, then check out, for example, the latest tag from, or a predefined tag from the Derby database, build Derby by using our JDK. Based on this, we can already see if we can build Derby with our JDK, and then run all the unit tests that are part of Derby with our JDK that we want to test. And based on this, we get really a lot of tests for all the binaries, which at the end helps us, and since this is open source too, helps us to have a really great chain to build binaries that is completely open, starting from our installer scripts, like the native installers for Windows, and so on. The sources from the Open JDK. Our build scripts are open source. They are running on an open Jenkins server, where you can just go to have a look at. On this Jenkins server next to the builds, the Aquavit tests are executed. The only thing that is not open source is a TCK, because we are not allowed to do this open source. And the binaries then, even if they are on adoptium.net, are hosted at GitHub, and adoptium.net just redirects to that location. So this is the second project that we have at Adoptium, and I have 1 minute left, but this is enough for the third project, because when talking about other distributions, we have a lot of them. And what I really like with this is that we, as Java developers, have the freedom of to choose what Java distribution we want to use. If we want to have a free distribution like Tamarin, if we want to have a distribution where we can buy commercial support for a maximum long time, like the Oracle JDK, so we can just choose. From my point of view, it's just important that the binaries that we are choose are solid and tested and enterprise ready. And there are two checks on the market, the TCK, the one that comes from Oracle, and Aquavit, that really provide, by executing them against the binaries, Java binaries that are allowed based on the TCK to named Java binaries that can easily be used with any application, starting from a small startup up to Twitter or Netflix, who are using binaries that in the future will be in the Adoptium marketplace, because this is the third project where we are currently working on, and I hope that it will be released within the next days, because that will be a place coming from the Eclipse Foundation, so not from one vendor, but from multiple vendors, where you can download all the Java binaries that have PEST, Aquavit, and the TCK coming from all the different vendors like Microsoft, like Azure, like Eclipse, and so on. And it has a graphical front end where people can easily download what they need. And next to this, it has a full API so that tools like IntelliJ or even if CI/CD tools that want to automatically set up any Docker containers can use it to automatically download the newest version with security fixes, for example, for Java 8 or 11 or 17 for a specific vendor, and yeah, know that whatever you choose from that marketplace, you have a Java version with a very high quality that is well tested and can easily be used in production. So, yeah, sadly, I was not able to talk about the migration part because I added a lot of new things to this presentation since the last time. But I hope, even without that last part, it was quite interesting for you. Oh, could you repeat the question? Oh, sorry, I missed to repeat one question that was coming from the audience. I hope you liked it. If you have any questions in the remote by chat or here in the room, and I try to repeat the questions that are coming here from the room. I think we have some minutes for questions now. Yeah.
Regarding the security patches, Adopt OpenJDK is now retired. They do not provide proof. It's all now on
Yeah.
Adoptium.
Yeah. 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 Yeah, the Tamarind ones. Yeah, yeah. Yeah, yeah, yeah. You can download the old versions, and as said, I mean, we can have a look at the. Oh yeah. So the question. Sorry. Perfect. Thank you. So the question was if Adopt OpenJDK still provides new versions with security fixes, or if we need to go to Adoptium to download those. And the answer is no, you need to go to Eclipse Adoptium and download Tamarind. So what we see here is the download count of Adopt OpenJDK. Especially what is quite interesting is that you see here that there are still people who download JDK 17 coming from it. And if we go to so here are the download counts from Adoptium. So as you can see, Adopt OpenJDK is still much higher because people are still downloading it. But this is growing quite fast. Yeah. And this is the future, and this is the one that you should use. And here you see that here you have even JDK 18 and JDK 19 and so on. Yeah. Yep. The good thing is that based on what we did at Adoptium is not that difficult anymore because you can fork everything that we have and just set up a Jenkins and use it in COE. We even had, but this is broken, sadly, we even had some time ago a Docker container that built a Linux binary for you. So you just needed to do like a Docker up and then in this container, everything, the OpenJDK was checked out and so on and so on and so on. And based on this, a Java binary has been created, but this is not working at the moment. But we have all the build scripts and all the things directly at GitHub. We even have forks of these. So let me show you. So under Adoptium, we have, for example, the installer repository. This contains the source code for the native installer. So if you do not want to have it as a zip, if you want to have a Windows installer or something like that, here we have the Aqua test, which is the Aqua test suite, the containers that contains everything to provide it in Docker containers. And here we have, for example, the Tamarin build, which contains the whole build script of Tamarin that includes the installers and so on, and checks out the Open JDK and so on. Yeah.
Some vendors say that they have some advantages over the Open JDK.
No, no. The some vendors have like so. For one example is Azul, for example, in Java 8. Java 8 has, I'm not a security expert, but they had this old SSL version still in Java 8. Somebody knows what I'm talking about, so you name TLS, I don't know, 1 point something. And Azul, for example, for their Zulu build, they introduced the newest TLS version, even for Java 8. So this is something that Adoptium does not do, because we do not add next to the installers things to Java. This is like the vanilla Open JDK that we provide. We do not have additional garbage collectors like some might have. We do not bundle, for example, JavaFX like some others do it. But this is again a little bit problematic, because I don't want to bash any company, but if you look how Amazon with Corretto introduces or just adds JavaFX into Java 8 by using a JavaFX version that is more than 2 years old, yeah, I mean, everybody can add it, but it's not supported at all. There are a lot of bugs in it. So, yeah. We don't do it. Others do it, and I think it's fine that others do it, right? That's what I say. You have the freedom of choose to choose what you want to have. Yeah. Any other questions? Yeah.
Security fixes still be applied to long-term supported version after end of support time?
No. So after the, I mean. No, it's not planned. Let's say it like this. So currently for the LTS versions like 8, 11, and 17, end of life dates are planned today. And from a today's point of view, nobody will contribute security fixes to the OpenJDK repositories of that versions after that date. But maybe the date changes, because that happens in the past too. And next to this, companies will fork then those repositories, and for money continue in private repositories to provide fixes and provide then versions with security fixes for money. And I think that's fair, right? I mean, you have more than a year to do a migration, and if you cannot do it within a year, then you need to pay for support. That's how the model currently works.
I ask because many projects or even maybe commercial products start supporting LTS versions near the end of LTS.
Yeah, that's a problem. Yeah. I mean, neither for Java 8 or 11 we are currently near the end. I think that's a good point. So all the LTS versions that are out today are still have. We have a list at Adoptium.net and support. I think it's where's support? Yeah, we changed. We have a new page. maybe it's under document support. Here we go. So here we have a list where you can see, like, okay, for Java 8, it's planned to at least May 2026. For Java 11, it's 24. And for Java 17, even today, there is no date defined when the LTS support of Java 17 will end. So here we still have some years even with Java 8 and Java 11. And from my point of view, most frameworks and libraries are now upgraded to 11 and work with 11. Java 17 is still kind of problem. If we, for example, have a look at Spring Boot, just as an example, where do I have it? I checked how it looks like with Spring Boot. So Spring Boot is, for example, still working on Java 17 support. So there is also versions that are Spring Boot 5.3 something, should work with Java 17, and I assume they work with Java 17. But the official version, based on the Spring migration guide and things like that, will be Spring 6. That will support Java 17. And this is not out now. But it's targeted, as you can see, for the end of this year. So, yeah. So the big ones are getting better in that. Yeah. Spring? Or who? Yes, yeah. So I think every company, or no, it's not even companies, we are not a company. Every vendor that provides open Java binaries, I assume, will do it. Maybe there are some small ones, I don't know how SAP, for example, which they have just a small distributions for some specific customers, maybe they then only support every second version or something like that. But all the big ones will support each version, yeah. It will be tough because, so this release, which happened last week, was the first release where we needed to release 4 different Java versions, with Java 8, 11, and 17 being now LTS versions. And actually, so I was not working that much in Adoptium, but we can have a look what the current state is, because here we see the checklist for the releases. So even that one is in, where's the, so normally there should be a release matrix. Maybe it's removed because everything is released. But even these things, right? Like the releases are handled in GitHub in open issues. Oh, is it that? Yeah, it's that one. Here we go. So here we see that, okay, we're still working for JDK 8 containers on Java. JDK 8 containers for AIX will never happen. Let's see, so there was like the Java 17 release for Mac ARM was a problem, and this is still not there because the Oracle TCK is still not executed, and I cannot tell why. Because it's closed, you're not allowed to talk about such things. Yeah. But even this is open as far as we can do it in the open, yeah? Is
that the reason when I was looking for the M1 JDK for macOS? Azul was the only one, or was the first one that I could have. Was I blind or?
No. Yeah, so with the M1, it was, the M1 thing is quite interesting. So we've seen that it's introduced in the Open JDK with Java 17. So starting with Java 17, everybody can easily do it. With Java 8 and Java 11, we at Adoptium do not have a release because we only build based on the JDK. Azul has, I assume, they did a private fork of Java 8, or they do a private fork of Java 8 and Java 11 for each release and merge, backport the support of ARM for Mac into it and build releases out of it. To have like a premium feature that makes companies, people use the Azul version, and that's fine. I mean, they even do it for free, right? They don't want money. They provide it for free and hope that people based on this will use the Azul binaries and then use it in future. But this is how it's working in the end. Yeah. Okay, good. Then, yeah, thanks for all the great questions. I hope you learned something. I hope you liked this information about OpenJDK and Adoptium. Okay, and so I think in half an hour there's a Java core panel in Gold Dingens Bummens 1. So if there are any additional questions, Falk will be there, I will be there. You can just come there and ask questions. Thank you.